I don't think I'm recording.
Oh, that is awesome. Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Al Williams.
This is episode 271, audio delay in a hose, ribbon cable repair, and DIY hacker metrology. This week in the news, we covered a story about a software bug that resulted in a huge recall of insulin pumps because of injuries people were suffering from them.
That's a subject I've talked about before. It's easy to go, oh yeah, and if you look, I think it was a phone app, right? The phone app crashes and that drains the battery every time it tries to reconnect. And so the battery gets drained. So it's easy to go, oh yeah, who cares? That's the phone app. It's not a big deal. Well, it's a big deal if your battery and your insulin pump dies and then potentially, I guess, you die, right? Or get very sick. You know, the classic in that is the Therac 25, another medical device that was like, oh no, it's perfectly fine. And it was irradiating people. There's a lot of things like that, though. And we've talked about that before, about how, man, you really have to be careful and think, what's the worst thing that can happen here? And am I preventing that from happening? And so Dan did a good job of writing that up. I know that's a topic dear to his heart. And, you know, it's very unfortunate that things like that happen. It's hard to imagine.
The app was crashing and restarting, which, as Dan points out in his write-up, sounds like the right thing to do. Like, you want the app to be running. So if it fails, reboot it and get it back running as fast as you can. Except, of course, if it's in some bad sort of loop, it just keeps doing that until it kills the battery from all the time having the radio on.
I mean, of course, you know, hindsight's 2020, so very easy to armchair quarterback this from after the play. But you would think you'd say, well, if I restart more than 3 times in 5 minutes or something, I'm going to go throw up my hands. But I don't know how hard that would necessarily be to do. But, you know, at the very least, the hardware could have ignored it and said, no, I shouldn't be getting reconnected to every 10 times a minute.
The good news is that they've caught this fairly early, although if you read the FDA's website, it sounds like, you know, around about 100 people have had this problem and had it actually affect them. So that's pretty freaky.
I'm sure all that had to be FDA certified, approved, because everything that you touch like that has to be. So, you know, I don't know enough about that to speak intelligently on it, but I wonder if that's going to change some of the rules for how that's done in the future. I don't know.
Yeah, I mean, it seems like it's, you know, like it's once removed, right? It's not the device itself, it's the app that controls the device. So it's kind of a little bit of an unexpected vector. Just goes to show. And then in Hackaday news, we just announced this week the call for participation for SuperCon 2024, and that's 2 newses in one. Part of the news is, not to bury the lead, SuperCon is going to be on again November 1st through the 3rd, Pasadena, California. I'm so looking forward to SuperCon this year, as always, and we're still in the very early planning phases. But the first and most important thing is to get some awesome talks there. So call for speakers and call for workshops are up right now. Like last year, we want to do long talks and short talks. So if you've got a 20-minute talk or a 45-minute talk, you can submit into kind of either track. We don't have any concrete date for tickets yet, so no secret news to give you on that front. But as always, speakers get in free. So the best way to get a ticket is, of course, through the back door, through the green room. Give a talk and you absolutely get a ticket guaranteed. So basically what that means is head on over to the links in the linked post and click on the form, start filling it out. And you've got until July 9th to get something together.
And we have so many great talks. It's always fascinating to see what comes in. And, you know, you always wish you could take twice the number that you get to take. So looking forward to seeing those myself.
Yeah, that's why we actually have the shorter talks track too. So that if the talks are shorter, you could pack more of them in. Hopefully we'll get a lot of diversity of topics.
This is a journey into sound. What's that sound?
What's that sound?
So that brings us to What's That Sound? This week, I couldn't find anything good, but Al came through. And so now I'm in the hot seat. So let's all have a listen together and see what we can figure out.
I can't decide if you get it, did I come through? Or if you don't get it, did I come through? We'll see. So
if there's a cool sound, you win. That's the game.
Well, here's the sound. Here we go.
echoey, white, noisy, bubbly. It's that whatever that bubble is. I think
You're on the right track. That's the significant part of the sound. Yes.
I think it is. Where would those bubbles be coming out of, though? I mean, it almost sounds like scuba diving, but
Oh,
it's a person who's not breathing very much when they're scuba diving. So which is good. I mean, that's what you want to do. It helps your tank last longer. So
less is more to a point, right? So
yeah, to a point, and then you get blue in the face. Is it a recording inside a submarine?
boy, you are so close, Elliot. So I think you should go ahead and ask people to give us their guesses, and I can tell you what it is offline if you like.
Sounds good. Those of you listeners out there know what it is. Head on over to hackaday.com/podcast. Scroll on down to the What's That Sound section. Click on the link. You'll find a form. Fill it out with your best guess and your handle. And next week, actually, I'm on vacation next week, but next week, Dan and Tom will take care of you and get you a Hackaday podcast t-shirt. Well, speaking of sounds, let's head on to the hacks. My first pick this week is kind of an absolutely low-tech audio hack. This is an audio delay the garden hose way. Is a video by Lookma No Computer, and he's actually teamed up with, so this is like two synthesizer nerd YouTubers teaming up together to make an album in a weekend. It's kind of a fun video one way or the other. But one of the gimmicks there is that they go out to the hardware store and buy a 15-meter long garden hose. And they put a microphone on one side and a speaker on the other and record the sound that way. And it makes kind of a very weird audio delay as the sound propagates through the hose. And I'm still surprised by how well it works. Like, it's an actual kind of audible delay in just like a crappy garden hose. It doesn't sound like an accurate echo. It sounds like a super muffly echo, I guess, which you would expect because they used a crappy little speaker. And to get the sound into the tube, of course, you can imagine big speaker, small hose opening. So you've got impedance mismatch. But how do you deal with impedance mismatches in the world of moving air? The answer is, of course, with a funnel. And so lots of duct tape and funnels and pipes and garden hoses. And they just stuck quite simply a microphone capsule in the other end of the tube. And that is it. And it's pretty cool.
Yeah, that was a Rube Goldberg for sure. The two things that crossed my mind, not being the audiophile that you are, I thought, well, first of all, have these guys ever heard of laminar flow, right? Because I'm guaranteeing you the funnel is not preserving your laminar flow. But also, it made me think, because I'm not a big synthesizer guy, I was thinking, I wonder if you could do a model of a Mercury delay line here, like the EDSAC had. The EDSAC was basically one bit CPU, and the bits would come through the Mercury, and you'd process one bit, and you had to get it off to the next Mercury line before the next sound wave came by. So it kind of got me thinking about that, but not that I'm going to do anything about it, but yeah, it was a cool idea, and it's one of those things where I don't think I would have ever dreamed this up if we were just sitting around talking about it, but now that I've seen it, I'm like, oh yeah, of course.
Yeah, the history, that's really interesting. The memory problem is, of course, the exact opposite of the audio delay problem. With the audio delay, you want to make it take longer and longer and longer. And I guess they were using Mercury because the speed of sound in Mercury is really, really fast, right?
I don't know. I think it's because of the temperature stability of it, because what you want is you actually want it to last a long time, because the longer it lasts, the more memory you have, right? But you want it to be very predictable. You want it to go, okay, this bit is now, and then in a millisecond, then's the next bit and the next bit. I'm not sure why Mercury was the choice for that. I should know that. I'll have to look that up. Maybe that's a Hackaday article in the future.
In the early days of computer memory, they also had funny spinning drum memories and stuff, right? Like where you could...
That was a little later, but yeah, not much later. But I think the big thing about the Mercury delay lines, and they used those in radar too, right, was just you did in fact get very clean timing. So I could easily say, okay, this delay line's going to take, 220 microseconds, and that's, in radar terms, that's this many yards or feet or meters or whatever country you happen to be in. So again, like you say, not exactly the same problem, but it did get me thinking about whether or not I could cobble up a Mercury delay line in the shop. So
Yeah, well, it's fun because the history of reverbs has been this kind of history of hacking weird stuff together, and it's kind of fun. It's all like if you think about you talking in a room, the sound waves come out of your mouth and they hit all these walls around you and they come bouncing back at you. And sometimes they take the direct path and sometimes they take the multiple bounce path. And sometimes they hit hard things that make a nice clean reflection, and sometimes they hit soft things that make it muffly because early audio engineers started recording instruments differently from each other and not always doing live recording, they kind of wanted to put them all back together and make it sound natural. And part of how natural sounds is then this five musicians sitting in a room kind of reverb coming back at you. So they invented all of these insane synthetic ways to imitate this reverb sound. And it's really, really interesting. And that's actually one of my favorite pet topics. I noticed Jenny, who wrote this up, threw in a link to the reverb room, the echo chamber, as they were actually called, in Abbey Road Studios. There's a couple of these old echo chambers still out there. I think the Motown one was also super famous, and you've heard the Motown echo chamber sound a number of times. And what they did was they really just put up a room with a speaker on one side and a microphone and just played the sound into the room. And then they had all sorts of baffles and stuff to make it effectively bigger and to make it diffuse the sound and to give it a couple different distinct echoes. And it's really extremely low tech. Like you really just put a speaker in the room and then record the sound that comes bouncing back. But that was like one of the first reverb ideas. And then there was all the electronic ones, which include the electromechanical, like spring reverbs, which would actually take essentially a slinky or, a stretched spring. And they actually work by rotating it because it's easier to transmit torsional waves down the string than it is to do compression waves. And those are really fun. I don't know. When I was a kid, we used to have a practice amp, the Fender Champ or something, and you could kick it, of course, and the springs go wiggling around, and they're really lovely sound. But then there was plate reverbs where they would do the same thing. They'd couple a speaker to a big metal plate, and you can't put it in the center. You kind of put it off the center, and the sound waves bounce out to the edge of the plate and then bounce back, and you can record those in a bunch of ways. Like all of these kind of funny ways to get the multiple bounces and the delay in there. So it's actually not that weird to do it with kind of muffly sound down a garden hose if you think about it. And actually the original device they had that they were kind of inspired by here, Luckma and Heinbach, was a two-tube device. It put the speaker into two different tubes of slightly different lengths. And so you actually had two different delays coming out of it, which made it kind of a more, quote, natural in big super muffly, air quotes, sounding reverb.
back on the other subject, I did a little quick research. Mercury was used because its acoustic impedance is close to that of the piezoelectric quartz crystals. So it was the same thing you were talking about. How do you deal with the impedance mismatch? Well, with the Mercury, you don't, and that was part of it. The original patents from J. Presper Eckert, they covered using Mercury, but also discussed, and I'm reading from Wikipedia here just to be transparent, also discussed delay lines used of strings of inductors and capacitors, magnetostrictive delay lines, and delay lines built using rotating discs to transfer data to a read head at one point on the circumference from a write head elsewhere around the circumference. So man, there's 3 or 4 Hackaday projects right there in a capsule.
I know we've actually covered it, but Jerry Ellsworth, way back when, did one where she actually took a, whatever they are, 3 1/4 inch floppy drive and read to it and wrote from it as it spun around and used that as a delay unit. So
There you go.
there's nothing that hasn't been done out there. But I think it's really cool because basically any way you can take the waves, re-encode them, and then, read them back off at a later time, right, is fair game. And so we've seen a lot of tape echoes. That's an absolutely classic reverb and really fun if you have like multiple read heads stretched along a piece of tape. So you record the sound here and then you can hear the different echoes of it as the tape slides by some more read heads. Well, throw some links into the show notes there. There's just all sorts of fun you can have with this, and it's surprising how low tech a lot of the earliest reverbs were, and they all were kind of this real, almost physical analog of how sound works in the real room. Like I think of the plate reverb. You have a transducer coupled to a big spring steel metal plate, right? And it like literally bounces the waves off the edges of this metal plate and back. It's exactly like a room.
The real question is, are you going to add some echo to this segment so everybody can enjoy that? Or
Echo, 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 echo.
Okay, my first pick for the week, Joris Clayton has the Protoboard Z80 computer teaches the basics. And on the face of it, perhaps this doesn't look like much. It's a Z80 computer. We've certainly seen plenty of those. But I think what really struck me is it was built all on perf board, and it was all pretty much a scratch design, right? It's not, oh, I took this particular design and just rebuilt it. And it made me think, we've kind of gone full circle to where, if we were having this conversation 10 or 15 years ago, we'd be talking about, well, it's a shame it's so hard and expensive to get PC boards made because I really want to have this PC board made, but I want to pay the $200 to have it tooled and the test fee and it's going to take 3 months. Now we live in the world where nobody uses this type of protoboard construction anymore, hardly, because I can just sit on my computer, throw out a PC board, and in 5 days it shows up in my mailbox. So, and it costs less than a cup of coffee. So I really I admired the design and construction of this, that it's all on these kind of modular boards with the plugs, and it's all just perf board, essentially. I'm a big fan of these computers that you can build that would have been amazing to us back in the, late 1970s, maybe even early 1980s. And I've actually, one of the few Hackaday projects that I've written up and then said, I got to go build that, and I'll put the links in the show notes, was for a $4 Z80 computer that would run CP/M. And the answer to that is, well, it's a Z80 and it's an Arduino that basically acts like almost all the other pieces of the computer. It's got like some RAM chips and it's got some serial double EEPROMs, but very low duty. This design is a lot more. I mean, you can see there's quite a few number of chips there. And you might say, well, why do I want to know how to design a Z80 computer anymore? But I think being able to put a whole system together like that from scratch is an amazing educational experience. Whether you ever actually have to do that again or not, maybe you don't. But I think if you can do that, some of the things we do now seem really, really easy compared to what, they would seem if you had not done this first.
Yeah, I think there's absolutely benefit in going back to the basics. And, you do have to say that the perf board method is the absolutely most basic of them in a way. Like, you understand something when you can hook all the wires up yourself, right? Like it's somehow there's a disconnect a little bit to, dragging the wires on the screen on your computer versus sitting there going, okay, this pin's this, and like physically wire it up to the bus or whatever. I think that's kind of neat.
I'd argue you really understand it when you can fix all the wiring you've done point to point.
That's right. And then you have to be able to debug this thing, right? And that's
like, well, it doesn't work. Oh, wait, that pin's off by 1. That's where you really demonstrate your understanding there, right?
That's right. And it's also kind of like artisanal computer manufacture, right? Like I think he's just having fun doing it as well. And it's,
Yeah, my limit's about 143 wires. After that, I always look at those back planes on the old computers that just look like a plate of spaghetti, all the same color wire, and I'm thinking,
right?
Who built that, right? Who is able to do that? I can't do it.
That's the equivalent of spaghetti code, right? That's like you can build it once, but good luck debugging it. Before we leave the topic of built computers, I want to say that we just put out the SuperCon talk from James Lewis, the bald engineer who built himself the ultimate Apple IIe with apparently Apple had a Apple on a chip that was supposedly going to put everything together, and he wanted to build a working computer out of it, and it took him a year and a half because A, no documentation, and B, getting all the details hammered out. But it's a marvelous talk, so you should go check that out if you're into DIY retro computing. Although in this case, it's DIY retro computing of a computer that never was.
So I had the pleasure of introducing James for that talk, and my son was there in the audience. And he likes to do a lot of this kind of stuff, but he's like at a more of a software level. And when we got done, he said, I didn't understand a lot of that, but he was so excited about it that I was really fascinated, and I thought that was great. And so he was really enjoyed the talk, even though a lot of it I think was maybe a little more hardware-ish than he's normally interested in. So great talk.
Well, my next hack then is maybe for your son. This is putting more software into your hardware. This is Bordos, a command line interface for the Pico, is a project by Calvin McKinley. It basically takes a free RTOS and the microshell project, puts them together and ports it over to the RP2040. I mean, among other things, it gives you a nicely colored interactive shell on the RP2040 itself. And the free RTOS, of course, does the kind of operating system thing. It lets you create subtasks and run them, launch them, but it's also got access to a file system. And you can also use a lot of the peripherals from the shell level. And that, I think, gives you an interactivity that shouldn't be discounted. I know whatever your feelings about programming in MicroPython, Al, it's really useful to be able to kind of interactively debug things sometimes when you've got a language that has this kind of a REPL loop in it. And this gives you a compile it in C, run it fairly quickly, but also concurrency and this interactive shell on the RP2040 chip. So I think that's really cool too. And this popped up in the comments. It's not the same as running Python on it. It's not you're running interpreted code. If you want your code to coexist with other things on there, you have to write it in C, compile it up, and then submit it to the operating system as a task. But all the other stuff, like, it's got low-level access to the peripherals in the shell. So you can say, write this out to the I2C port, or, read me the value that's coming in on the ADC1. You can do this kind of interactive debugging on the command line as well. But then if you want to write your programs for it, of course, they're in C somewhere, and you compile them, upload them, and link them in.
Well, I know sometimes we do differ, but I know we're both fans of things like the fourth development cycle and even
Right.
MicroPython. I mean, that's one part I will say I do like being able to just interactively go after it. I think this is a nice alternative for that. It's based on free RTOS, so you think it's pretty capable. I think it tries to mask some of the complexity of free RTOS, which is welcome as well. So, the only thing I have always mixed feelings about deploying stuff that with an RTOS, because I think you should always ask yourself, did I really need the RTOS, right? And if the answer is no, maybe you should only use this to develop and then get off the RTOS. I'm thinking like the Toyota brakes, right? Where, that was something that probably needed 10 lines of C code, and instead it had a JVM and I don't know what all it had, but it had an operating system and everything. And of course it failed miserably and did bad things, kind of going back to our insulin pump discussion. But that doesn't mean OSs are necessarily a bad thing. I think sometimes we use them just because, that'll be easier, but maybe it isn't really. If it's something really easy, maybe you shouldn't be doing the OS. But given that you need something like this looked like it was really well thought out and really well done. I haven't tried it yet, but I plan to. My next hack is actually a repair hack from Spare Time Repair, and it's the Impossible Repair ribbon cables. And I think that appealed to me because I have certainly been in this situation before where you've got one of these little delicate, flexible ribbon cables and it goes bad, and now what, right? And there's a variety of really ugly, unpleasant hacks you can do for that. What Spare Time Repair did was actually took a vinyl cutter and cut a pattern of tracks into some aluminum tape on a sheet of plastic and essentially made a new ribbon cable. And so I was very impressed. If you recall, just the other day I mentioned, what excuse can I use to buy myself a vinyl cutter? I think we found it, right? So, wow, I'm not sure what impressed me the most, that he was able to do that, or just the fact that, as I always say, I know I sound like a broken record, but wow, we have all these tools at our disposal now that are relatively inexpensive compared to, I can't imagine 25 or 30 years ago somebody fabbing this ribbon cable in their shop for some reasonable amount of money. we've talked before offline about how precise those cutters are. I would say this one, whatever one he used, must have been pretty precise because if you look, it looks great. It does look like the tension bar might leave a little something to be desired there because it looks like it's a bit that's the hack part of this, I think. If you've ever got a broken ribbon cable, this would certainly be something to investigate. And even if you don't have that kind of cutter, they're plentiful. So my guess is the hacker space or even a sign shop that had somebody bored and amenable to a $20 bill would probably do something like this for you. So
That's funny. A bunch of people said this in the comments too. I was just looking through, waiting for somebody to say he should have used copper tape. And lo and behold, you scroll down the comments, some people did. I've had this problem where I've tried to make funny circuits like this out of tape. Let's see, and the adhesive isn't conductive, so it goes the wrong way through. But here, I guess he's getting around that because he's taping to a sheet of plastic, so the tape's on the kind of the wrong side anyway, and it just works. I wonder if he cut it like extra long and then trimmed it to size so that, the edges where it gets messed up anyway.
yeah, and I wonder if it would have cut copper tape. You'd think it would.
I would think.
I did an article for, where was that? Like 20 or 30 years ago now, where we took copper tape and if you don't know about copper tape, which I know you do, but for people listening, if you don't know about copper tape, the people use it for stained glass. And so you would take an old shoebox and lay out your circuit on top of the shoebox with the copper tape. Anywhere the tape touches, you need to solder because, like you say, the adhesive is not conductive, so the solder blob like shorts out the two pieces of copper. And if you don't have ICs in something, that makes a really nice way to make a cheapo PC board without any chemicals. So I had like a little Morse code transmitter with a transistor and a 1 or 2 transistor regenerative receiver, both on shoe boxes. And it's a pretty cool method. But of course, once you start trying to do ICs, it's not funny anymore.
It's funny you mentioned without chemicals because my last experiment, man, this was about a year ago now. I never wrote it up because it was basically a failure, was to take copper tape and draw on it with Sharpie to make an etch resist and actually try to etch it. So I was trying to make essentially circuits on the, using tape wrapped around a bottle, right? But the idea was to make, round circuits or circuits on strange substrates, right? And the etching was horrible. And you're left with this like gooey residue from the glue. And the etching cuts across the sides. It like undercuts pretty badly. And I just got a horrible result. So
That sounds like a fail of the week to me, Elliot. You should have wrote it up.
but I was able to solder an SOIC 8 to the thing. So there you go. I could do surface mount parts on it. It just was so gooey and gross with all the like half melted tape glue that you didn't want to do it. Then my next hack is adaptive chef knife provides better leverage. This is a really cool project aimed at being an assistive technology project to make a 3D printed handle for a kitchen knife that's easier to use for people with mobility problems. And this one's really cool because if you think about how you hold a knife, the handle's usually straight in line with the blade. And so you have to turn your hand at this kind of funny, almost 90-degree angle to grab the thing and then cut with. And so the design here then has this handle at 90 degrees to the way the blade's cutting. And then it has another part that goes up under your arm and serves as a brace. So basically the knife is like this extension of your hand, like it's completely firmly held on there, both by this brace that grips your arm and by the 90-degree angle handle. So it's a really cool idea for people who have trouble using their wrists like that, like if you think about how you use a chef's knife. But then I think it might be fun just to try. And this comes out of the Illinois Assistive Technology Program, and they are making 3D printed designs that you can then modify yourself to fit the tools you have to use. And I think that's what's really cool about this is it looks like something, I don't know how many of their users are as savvy as the average Hackaday listener, but you could certainly imagine taking a kitchen knife you had downstairs, and instead of taking the handle off of it to build into this thing, you could actually probably just model the existing handle on there and then make this kind of extra accessible handle that would grip it and turn it into this kind of crazy knife. I guess you could 3D scan the handle so that you got a really good model of it, and then just make like a shell around it to turn it into one of these knives. Might be really neat to see.
Well, I always think this is one of the best uses of 3D printing, not necessarily the knife handle, but just the fact that you can say, well, there's 1 or 2 or 5 people that have this problem, and we can create something that will solve it for them. And even though person number 3 has a slightly different thing, we can modify it, right? You have a different brand of knife or whatever. That would have been so hard to do before, where you'd say, well, I got an injection mold made, and that's not going to happen. You were mentioning about people aren't as savvy about 3D printing, but there's been a long history in the ham radio community. There's an organization called Handy Ham, where people go out and try to find ways to use technology to help people who need that kind of help. And so I would think there's other organizations, or maybe even Handy Ham, that if this was something you needed, that there would be people willing to help you do that, even if you weren't a 3D printer or had access to things like that. We aren't the only ones to notice that. Back in 2015, and I put a link in the show notes, I did a piece on UTMB, which is the University of Texas Medical Branch. They actually have a hackerspace that's made for medical assistant things, and it can't be anything like a super invasive medical device, but you say, well, a nurse notices that this IV keeps getting caught, and if they only had this little clip that would clip it to this other thing, that they could make that clip. And so someone there will help them design it and print it, and it can be tailored exactly for the patient. And so I think there's a huge amount of good that you can do with that, especially the FDM printers. I mean, there's just so many keychains you can print, right? And there's it's not necessarily something that you're going to use every day. But this kind of stuff could really make a change in somebody's life, and it is something that would be very difficult to do by either just fabricating it one-off or doing it at scale when there's just not a scale amount of people that need it. So I thought this was a great project. I'd like to see more of this.
I should mention that I kind of undersold this. This is actually a really interesting use of 3D printing. So in terms of actual fabrication, what they do is they take the handle off the knife. So you've got the tang there, and it's got a couple holes drilled in it, that used to attach to presumably the wooden handle. They've made this 3D printed form that, is the assistive handle, but it's actually hollow, and they have a 3D printed mold that contains it, and they're using fiberglass to surround this thing. So the actual knife itself has a 3D printed matrix on the inside that kind of takes up space and prevents them from having to use so much epoxy resin. And then it's got an outer shell of fiberglass and epoxy, so it's also food safe and whatever. And this is, of course, made easier to manufacture by having a custom, again, 3D printed with a little rubber gasket on it mold that goes on the outside. So it's actually a really cool fabrication technique as well. I'm kind of stoked by what a cool looking knife this looks like, but it also is a really neat fabrication method. So you should go check it out for that, even if you're not interested in making yourself a fancy knife.
Okay, my next hack is from B Major Spin. Vibrating Braille display is portable. This is another adaptive, assistive kind of device. Now, I'll grant you, this one's 3D printed on the case, but that's not really what makes this possible or feasible. But the idea is if you have a phone, and phone's almost a necessity now, a smartphone, if you can't see the screen, what do? Well, that's easy, you say. All of them have the accessibility now. They'll read what's on the screen to you. But think about how annoying that would be, because first of all, there's a lot of data to go by. And then also, if you're like in the store and your phone's reading what's on your screen to you, that could range from annoying to extremely embarrassing, depending on what's on your phone. There are things that will translate through to Braille, but according to B Major Spin, they're expensive and bulky. So you get your phone out and then you get your bulky Braille reader out, and it's pretty expensive. So his goal was to build something that would attach to the phone, which it does magnetically, and that you could pretty easily use to see what was on the screen using Braille. He kind of had limited success with it. I mean, he admits that this is kind of a first draft proof of concept and it needs some refinement. But it was a very interesting idea. Essentially, Braille's only got 6 dots in the cell. So there's 6 little vibrating motors in there. So if you got your fingers in the little wells, you can feel which ones are vibrating, and that's the raised dots on the, to read the Braille. It turns out that's harder than you would think, because the little 3D printed case, if you just naively mount the motors to them, you can't tell which one is vibrating. And so he has to use like a spring suspension to keep them from vibrating each other so that you can say, oh no, it's the one under my index finger is vibrating, not all of them. I think part of it was he did not use PWM on the motors, and so I imagine the motors are rotating too strongly. And I think that was part of his problem, because apparently there's still enough vibration that it was difficult to distinguish if they were going fast. So there's a limit to I think that was the biggest complaint he had, was that it was not very fast to use this. And of course that kind of negates some of the value of it if it's got to go really slow for you to be able to pick the letters out. The other thing, and I didn't really see where he mentioned it, but I think it came up in the comments, is I guess there are several levels of Braille. And so, yeah, just sending, here's an A, here's a B, here's a C, that's one level of it. But there's at least 2 other levels where you either kind of run it all together so you get a little better speed. That's harder to learn. And then also there's the third level where there's all sorts of odd symbols and things that are not common. And I guess that's even harder to learn. So there's probably a lot of work that needs to go into this, but it's a clever idea. And honestly, I wondered, I don't know if I mentioned it in the write-up or not, but I wondered if maybe little solenoids would have even been better, right? You could literally just have a pin poke you in the finger instead of vibrating. But I don't know, maybe not. I don't know if that would be easier or harder. But it was a pretty cool build. It did do what it set out to do. And even though I think he was a little down that it didn't do it as well as he hoped it would do it, I thought for a first effort it was great. I think it was pretty inspirational, and I'm hoping either he or some other folks might go further with it.
My first quick hack this week comes from Robert Keim. It's an introduction to MOSFET switching losses. Like, we always think of MOSFETs as being idealized switches. It's on and it's off. But in the real parts, there are at least 3 different losses you want to worry about. One is the conduction loss. It has some little bit of resistance passing current through. 2 is switching loss. It can't turn on and off instantly. And 3 is gate charge loss. To turn it on and off, you essentially have to charge up a little bit of a capacitor between the gate and the channel. And so he breaks these down for you, and if you've never really taken a good hard look at MOSFETs, or if you're going to do some design that needs to be high frequency or moving a lot of current, you should definitely give this a read to get yourself a little bit oriented. Next up, non-split flap clock does it with fewer flaps is a really cool project by Shiura. I think it's the flip flap clock, because instead of the flaps being cut in half, these ones have 2 sides and they kind of flip over as they rotate around the clock. So he gets to use half as many flaps because each one has a front side and a back side. There's like a perpetual calendar design that I was looking at last week sometime that does essentially the same thing. This is that, but in bigger desk clock format. Really cool. JTAG hacking an SSD with a Pi, a primer, is a really neat look at a new piece of hardware by Michael Alt, otherwise known as Wrongbaud around these parts. It's a hat for a Raspberry Pi that does voltage level transition and breaks everything out for you and just makes it super easy to dig into microcontroller and other embedded systems with JTAG or Serial or whatever. It looks like it's kind of a Swiss Army knife. I like the idea of putting it together with a Raspberry Pi because it lets him control the software at the same time as the hardware, and it makes it kind of an all-in-one package rather than having to worry about installing stuff on your main computer. And last up, this one's just silly, but I love it. This typewriter types toast. is a intentionally goofy art project by Ritika Kedia, and it has little pieces of nichrome wire in the shape of letters on the end of old manual typewriter arms that then burn letters into a piece of bread. I think this version only has 3 of them, and it's a logistical nightmare to make any more, but it gets the point across, and the point is this is a funny, whimsical machine.
Yeah, I want the laser version of that where I, laser engrave my toast every morning.
Oh, I think you've got it, right? Your laser engraver is that.
Yeah, you could do the weather, the stock report, the whole thing, your daily calendar, all on your toast. I think that would be
Blue
great.
LED laser is exactly what you need.
Okay, my quick picks this week. Miguel Grinberg has How AI Large Language Models Work Explained Without Math. And I'll be honest with you, it's hard enough to explain it with the math. So I'm not 100% sure this is going to turn you into the guru of all large language models. And even if you go read some of the stuff, like I know the Wolfram guy has quite a bit of work on that doesn't shy away from the math, the thing you come away with is still no one really understands exactly why it works as well as it works. But you can at least understand what people do understand. And I thought this article was actually pretty reasonable as far as saying, well, here's kind of how these things work. A while back, we covered how you could do GPT-2 in a spreadsheet. So if you prefer reading code rather than prose, it's kind of that same level of thing. It's not going to teach you all the details. It's certainly not going to teach you things that no one actually understands yet anyway. But if you're looking to get a grip on that technology and at least get some understanding of it, it's a pretty painless read. This next one is Mr. Solder Fix, Tweeze Your Way to Soldering Success. Honestly, this is one where the post was good, but the comments were also good. And nowadays, if you're not using tweezers when you solder, then you're probably working on old stuff because all the new stuff is teeny tiny. Plus, in my case, I'm getting older and can't see any of it anyway. So I've got increasingly better magnification and tweezers. I do think, too, it's one of the things that if you haven't grown up in that, you probably don't have a lot of opinion. Everybody's got their own thing. Do you want the curved tweezers? Do you want the straight tweezers? I have found for certain things, not everything, some of those great big stamp collecting tweezers are actually not bad for things, the ones with the big flat plates on the ends. So it really kind of depends on what you're doing and what your personal preference and level of clumsiness is. But the comments on this one were really gold too, because everybody's got their opinion and everybody voiced it. So between the actual post and the comments, maybe get some ideas about your next tweezer purchase. And I always love the ham radio ones. R2AUK, who's Alex, has built version 2 of his ham radio transmitter. It's on GitHub. All of it's on GitHub. And it's very impressive. I mean, there was a time when you'd say, oh, a ham built his own transmitter or his own receiver. In this case, it's a transceiver. To go back to an earlier discussion, it was on a shoebox with copper tape and had 1 or 2 transistors on it. Now, that's not the case anymore. This looks like something you could have bought on this, from a store, covers all the bands, has a keyer built in, up to 10 watts of power output, which is not huge, but it's very respectable. And, it's a great build, made possible, of course, by so much of the integration. It uses an SI5351, and there's a lot of comments in that one about whether that was the right chip to use or not, but it does seem to work, and it seems to work really well. So if you're interested in ham radio, check out that design.
Well, that brings us to our can't miss articles. These are long form pieces written by our fantastic Hackaday writing staff. This week I got Anne Ogborn's Measure 3 Times, Design Once. Anne's a mechanical engineer and brings that down to kind of the hobby hacker level in a really fantastic way. And this piece has a few kind of ad hoc do-it-yourself measuring equipment builds, for lack of a better word, that will at least give you ideas about how to measure things like force and torque and super small distances and rotational power. So if you're building like a small robot and you want to know how much torque does it need to push this thing up a hill, what motor should I buy to make this work? How hard is this pressing here? These are things that, let's be frank, a lot of us, we just wing it. We're just like, I'll get a motor that's big enough and hopefully that'll work, right? But these are things that you can measure. And that's kind of the point of this article here, is that it's going into a bunch of simple tools that you can make that'll help you get a handle on these things. And I really love some of these. Yeah, the distance measuring things, they're things we probably all have kicking around. I mean, she says you need a dial caliper and some, measuring gauges and, those feeler gauges, the thin leaf gauge, the thin shim ones. Yeah, I absolutely standard things around my house. But it gets interesting where she mentions a push stick, which is basically a spring in a tube with a little plunger on it. So it's kind of like a syringe, except with a spring in the middle. And the only thing that's clever about this is that what she's done is to calibrate how much force is being put on this springy push thing, so that you can then measure that force later. And she does it by taking it and pushing it into a scale, reading off how much weight's on it and putting marks on the tube as it goes up. And I think that's really pretty clever. She also has kind of a DIY letter scale for measuring super small forces. It basically, again, it's the same thing. You just exert a force on it, measure the deflection, draw a line on a piece of cardboard, and repeat. A lot of these devices are just kind of plus or minus 5%, plus or minus 10%. They'll get you in the ballpark, but they'll get you in the ballpark with an actual number that's actually, dimensions and units and this many newtons, right? Like you can actually then go and buy the right motor for it using these as specs. And I think that's really cool.
I'm always amazed at how ingenious people are about measuring things. So, the caliper, and she just mentions the caliper and kind of assumes everybody knows how to use it, but there's all sorts of things on the caliper. So if you want to measure depth, that's the little piece that sticks out the bottom, right? And there's the inside diameter and the outside. I was struck. I saw a YouTube video the other day. We didn't post it on Hackaday. It's kind of a little off topic, but I'm sure you've all seen the sewing gauges, which looks like a little ruler, and it's got the little usually red plastic slider, and it's got all these notches and holes. And it turns out every one of those notches and holes has some meaning, right? There's some reason they're there. And this guy goes through and shows all the reasons. And I've seen those all my life. I never realized what all that's for. The letter scale, that's another one. That's a very clever arrangement. The U.S. Post Office used to actually be willing to give you these. I don't think they do it anymore, but they'd give you a set of like 4 little pieces of plastic with some spring steel in between. And so they were shaped kind of like a M almost. And you put your letter on it, and if the bottom of the M touched the table, then that was the weight, right?
Oh, right.
So it was like, okay, you knocked down the 1 ounce. Okay, did you knock down the 2 ounce? No, then it's less than 2 ounces, But so you could get those for free from the post office for a long time. I don't know if they still make them. So there's all these ingenious ways, as my old algebra teacher, Mr. Harder, used to say, you got to take what you know and use it to get what you don't know. And I think these kind of homemade scales for push sticks and letters and prony brakes and all that, that's all very reminiscent of that. It's amazing to me how ingenious human beings are. So
yeah, it's exactly right. It is precisely take what you know and use it to get what you don't. And it reminded me of the kind of early evolution of machine tool building, right? Like this is how you can make a flat surface 16 different ways. And then once you can make a flat surface, how can you make something that rotates smoothly? And then, you eventually end up building lathes and mills and all of modern machining. There's a little bit of that flavor here. Like she's actually proposing ways to make your own torque meter yourself, just out of stuff you got, for small torques, not for, I'm measuring this. It's not a dyno for your car or whatever, but for the kind of smaller projects that we're into, it's just right. And I think that's kind of fun. if you've got a known weight, here's a bunch of ways you can turn that into things. Or even if you've got an unknown weight, but you've got one good scale that you can weigh it with, here's how you can kind of lever that into more and more interesting measuring apparatuses. I think that's cool.
Yeah, great post. Well, my pick this week was from me, Al Williams, and it is decidedly not useful. If you've been following along, I just went down this rat hole. A couple of weeks ago, I wrote up, months ago, I guess now, I wrote up about bit slice computing, and it was really just kind of a history piece. And I said, I should look and see if there's anything you can buy for that. Well, as the hacker gods would have it, there was a pristine evaluation board for the AM2900 bit slice on eBay for way too much money. And those are uncommon. I mean, I did the search on eBay's completed auctions. It's not like, oh yeah, that was the 8th one this month or something. No, they're apparently pretty rare. So I paid way too much money for it. You're welcome. It wrote up an article on it, which was a couple of weeks back, on just using it. And in the process of doing that, I built a spreadsheet that let me put in kind of symbolic code and get the binary bits out that you got to flip the switches to put into the board. I actually made an offhand comment on that video, and I said, well, who knows, maybe I'll make it a simulator in the spreadsheet. And of course, you know how it is. Once you say something like that, it gives it power. So I did. I made this Google spreadsheet that can very slowly, I think it's about at the same speed as the board actually, can execute programs that were made to run on the board. So it's pretty entertaining. Now you might say, who cares, right? I'm never going to do that, and I don't want to do it. Fair enough. But I think the reason I wanted to talk about it today is I really got to thinking about it, and I thought, consider this. Pre-internet, no matter how interesting this was to me personally, where would I have found a board like this, right? Some guy in Wisconsin has one in his shop. He wants to get rid of it. How's he going to find me? How am I going to find him? How do we know what a fair price is? And then what's more is, a couple of clicks in Google, I have all the documentation that's ever been written for this board and this chip. Where would that have come from? So kind of like I was saying with the PC boards, and I frequently say that about the manufacturing technology, I think that's another facet that we really have gotten spoiled with is if you lived in some odd area of the country or the world, where would you find this stuff? And now you can go browse eBay or other places and find all sorts of exotic equipment. I know a lot of us have the hobby of browsing for the new gadgets on some of these sites. I won't mention anybody's names, but you know what I'm talking about. And so Jenny does that every so often. I spent $9 on an oscilloscope. Is it any good? Well, surprisingly no, or unsurprisingly no, perhaps. But think of the access we have to that. When I was a kid, I grew up in a relatively small town. None of these have ever been anywhere near where I grew up, ever. So where would I have ever found one? I thought that was kind of an interesting thing to think about, is how much things have changed over the last few decades to where we've got this global marketplace, access to all this stuff, and even more importantly, access to all the documentation. I should throw it in the show notes, but I did a piece a while back about how important it used to be to hoard data books. And we all did that, right? You'd get these data books from the manufacturers and you'd borrow them and not return them and, do anything you could to get them, because that's how you found out how all this stuff worked. And now, you go to Google and 2 minutes later, you've got everything that's ever been written on it. So it's pretty impressive.
I love the idea of making a spreadsheet to do this. And it's not even a spreadsheet. It's a spreadsheet in Google Sheets, right? So this is you typing stuff into a browser, which is basically like its own operating system that then runs JavaScript internally to then take this and turn this into this machine from the mid-'80s? The late 70s?
Mid-'70s to early 80s, yeah, probably.
That's fantastic.
It's a horrible hack. I mean, I'm ashamed.
The levels of overkill are just fantastic here.
Yeah, it's shameful the things I make spreadsheets do, and I've apologized for it many times.
All right, well, that wraps it up for this week's Hackaday podcast. Thanks very much for listening. If you see anything cool or do anything cool, write us at the tips line, tips@hackaday.com. And to follow along with all the links we talked about, head on over to hackaday/podcast. And until next week,
keep those hacks coming. I show that I'm recording. I'm sure all this is going to feature prominently on the after track, so.
But you don't want to go to YouTube to look for stuff anyway. Go to Hackaday.
I wasn't planning for you to put this on the air, but yeah.
Go to Hackaday. This is a family show. Let's hit stop and call it a day.
I'd hit stop if I knew how. Always on top. Show context menu and menu bar.
DIY measurement tools, making DIY measurements, making